Be thankful for everything that happens in your life. It's all an experience. Said by Roy T. Bennett. Hello dear friends. Now let's start something new. So this part I have included in my video lessons that every day will be starting the day or the lesson with one good thought. Actually, the condition at present which we are facing is what? Full of stress, full of somewhat sadness, somewhere the joy is what? Totally lost. Everybody is what? Doubted that whether he or she is safe, whether I am safe or no. Okay, so just will accept this everything by the positivity, and whatever we are getting in our life, that we will be considering as an experience, and definitely we need to be thankful towards the things happening around us. Even Corona-19 is also having the two sides. Okay, some bad effects are also there, and even for nature and for somewhat family time, it became somewhat good thing too. So we need to consider both the sides of Corona-19, and that's why I said that be thankful to everything that happens in your life, because it is all an experience. Okay, so just we'll keep it in our mind this thing, and then we'll go towards the academic part. Right now we are dealing with the chapter number 6, triangles. Okay, successfully we have completed exercise number 6.1, exercise number 6.2, exercise number 6.3 also in 4 different parts. So right now today we are going to start with exercise number 6.5. Okay, but before starting that, the important theorem. Okay, what is that important theorem? If two triangles are similar, then the ratio of the areas of these two triangles is equal to the ratio of squares of the corresponding side. In other way, very simple, what it is, if triangle ABC and similar to triangle PQR, if these two triangles are what? Similar, then according to theorem, the area of triangle ABC divided by area of triangle PQR will be equal to the square of corresponding side, that is AB upon PQ square, BC upon QR square, and then AC upon PR square. Before this, the proof part was also there included in your syllabus, but due to COVID-19, the proof part is not there during this year. Okay, so this is what one of the important theorem. When the two triangles are similar, then the ratio of their areas is equal to the ratio of squares of their corresponding side. Okay, so now just we will be seeing the application part of it. So here we go with exercise number 6.4. Let ABC is similar to DEF. So the sum is triangle ABC similar to triangle DEF. Sum number 1. This is what given. Okay, and their areas be respectively. So areas also given. Area of ABC is equal to 64 centimeters square, and area of BEF, okay, that is equal to 121 centimeter square. Then let EF, side EF, okay, is equal to 15.4 centimeter. Then what you have to do? You have to find BC. How can you do now? The application part is what in front of you. Already it is given the triangles are what? Similar. So how can we solve? Given that triangle ABC similar to triangle DEF. So therefore what we can say? Their areas the ratio of their areas will be equal to the square of the ratio of the squares of their corresponding sides. So what is, which side is given? EF. EF means second and third. So we should take BC. So BC upon EF. It is what? Square. Area of ABC upon area of DEF is equal to BC upon EF square. Here only the area will come, but here the square of sides will come. It means ABC's area is already given 64 upon 121 is equal to, now BC square, okay, and 15.4 square. Either we can write it like this or in bracket. Now what we'll do? We'll take square root both the side. Okay, so take square root. What will happen after taking square root? It will become 8 upon 11 is equal to BC upon 15.4, because here the square of 15.4 is there. So here only 15.4 will come. After that what will happen? The simple thing, that is the cross multiplication, which we were doing from so many years. Okay, so BC is equal to 8 into 15.4 upon 11. Okay, so 11 ones are 11 and then 11 fours are 44. Then 8 into 4 is what? 32. Right? And 8 ones are 8. 8 and 3, 11. So the answer is 11.2 centimeter. Now, sum number 2. The diagonals of trapezium ABCD. Trapezium ABCD. So let's draw the trapezium ABCD. Say A, B, C and D. The diagonals of trapezium ABCD, it means like this diagonal, and then the second diagonal is what? Like this. The diagonals of ABCD with AB is parallel to DC, already we have done. Meeting at what point? O. If AB is equal to, what is given? AB is equal to double of CD. So here we need to change these options. That is A, B, because AB is double of CD. So CD should be what? Small. Okay. A, B, C and D. Right? Okay. So this is what? AB is equal to double of CD. So what we have to do? Find the ratio of areas of triangle. That is, find area of triangle AOB upon area of triangle COD. AOB is what? This one triangle, and COD is what? Triangle number 2, the upper part. Now since we don't know any side, okay, we don't know any side, we don't know the numerical value of any side, so how can we get the area? It is simple, by using the theorem given. Okay, but before that we need to prove that these two triangles are what? Similar. So what we'll do? As usual, in triangle AOB and triangle COD. Of course, what it is, since these two lines are what? Parallel, so this triangle will be equal to this angle. This angle and this angle will be equal because alternate, and this is what? Vertically opposite angle. Right or no? Yes. Now, since the numerical value for the side we don't know, okay, so directly we cannot find out the ratio of the area, but we know that if these two triangles will be similar, so we can find out the ratios of their area. Okay, so what we'll do, we'll prove that these two triangles are similar. So let's start in triangle AOB and in triangle COD. The first one is what? Angle AOB is equal to angle COD. Why? Because vertically opposite angles. Then the second one is what? AOB we have done and COD we have done. So we will be going for this now. That is angle OAD. B means OAB, say angle number 1, and then this is what angle number 2. This is triangle. Right? So angle number 1 is equal to angle number 2, which is that OCD. Why? Because they are what? Alternate pair of angles. Because the lines are what? Parallel. Now since these two angles are equal, it means these two triangles, that is AOB is similar to COD by double AB. Okay. Therefore, what we can say, now the triangles are similar, so we can find out the ratios of their areas, that is triangle AOB upon area of triangle COD. It will be equal to what? AB upon CD's square. Now, do we know the value of AB and CD? No. But we know the value of AB in terms of CD, which is equal to what? AB is given what? 2CD. So, 2CD upon CD and its square. But this CD and this CD will get cancelled. So, what we are getting? We are just getting 2 upon 1's square. So, what we can say? Therefore, area of triangle AOB upon area of triangle COD is equal to 2 square is what? 4 and 1 square is 1, or 4 is to 1. Okay. So, hopefully understood. Now next sum. In figure, ABC and DBC are on same base BC. Then what we have to show that area of ABC upon area of DBC, means the ratio of their areas, is equal to AO upon DO. Let's see how can we do it. If directly you will see that there is what a difficulty you will feel. So what we can do, let's do some construction. What it is? In construction, draw perpendiculars on BC. So suppose I am taking it here like this, and here it is what? Like this. Okay, so here it is AP and here it is DM. Okay, so draw AP perpendicular to BC and DM perpendicular to BC. Okay, so if we will go ahead with the triangle's area, so we will come to know that area of triangle ABC upon area of triangle DBC. Since here we don't know that they are similar or no, so we will use the general formula. What is general formula of this? It is half into base. What is base for ABC? It is BC. And what is height if you will see for ABC? Okay, the height is what? AP. Similarly, for this also the common base is there, so half BC, and then what is altitude or height? It is DM. So this and this will get cancelled. So here we are going to get our first equation, that is area of triangle ABC upon area of triangle DBC is equal to AP upon DM. That is equation number 1. Okay. Now, moreover, what we can do is, now we have to prove this AP upon DM is equal to some other sides. Okay. So what we'll do? We'll do now in triangles APO and in triangle DMO. We'll try to prove these two triangles are similar. How it will be? We can see that angle APO is equal to angle DMO, because what? Both 90 degree, right? Now, what is second? Second is angle AOP is equal to angle DOM. Why? It is vertically opposite angles. Okay. Therefore, what will happen? These two triangles, that is APO, will be similar to triangle DMO by double A rule. Okay. Now, if these two triangles are similar, so there all the corresponding sides will have the same ratio. So therefore, what we can say? Therefore, AP upon DM, we can write it like this also, AO upon DO. Now, AP upon DM in 1, AP upon DM in 2. So what we can say, therefore from 1 and 2, area of triangle ABC upon area of triangle DBC will be what? AP upon DM. In place of that we will write AO upon DO, which is what I have required result that we need to show. Now sum number 4. If two similar triangles have same areas, then prove that they are congruent also. So how it will be? So let triangle ABC is similar to triangle PQR. What is given? Area of triangle ABC is equal to area of triangle PQR. Now we know that these two triangles are what? Similar. So then all the corresponding sides will have the same ratio. Or the other theorem is what? If the triangles are similar, so ratios of their areas is equal to triangle ABC upon triangle, area of triangle PQR is equal to AB upon PQ square is equal to BC upon QR square is equal to AC upon PR square. Right. Now, but these areas are what? Same. So, same upon same will give you 1. Okay. So, 1 is equal to what? AB upon PQ square. Okay. Now since these both values are same, that is AB upon PQ is equal to 1, it indicates that AB is equal to PQ. Okay. Then similarly, what it will be? BC is equal to QR and AC is equal to PR. What we are getting? All the three sides are equal. So therefore what we can say, triangle ABC is congruent to triangle PQR by triple S rule. So we have proved the required thing. Point D, E and F are respectively the midpoint of AB, BC and AC respectively. Then prove that or find out the area of DEF, okay, upon area of triangle ABC. This we need to find out. So let's go on. What is given? The given things are what? D is midpoint of AB, right? Similarly, E is midpoint of BC and then F is midpoint of AC. Okay. Now, by using by midpoint theorem, remember you have studied in grade 9 by midpoint theorem, what we can say, if D and E are what? The midpoint, so DE will be parallel to AC and half of AC. Okay, so DE is parallel to AC and DE is half of AC. Similarly, EF, okay, EF is parallel to AB and EF is half of AB, and the last one, that is DF, is parallel to BC and DF is half of BC. Okay, these are what the result what we are getting. Now we have to use this result in that triangle. Now if we will talk about this triangle, so if you can see that DBEF, okay, DBEF will become parallelogram. Why? Because DF is half of BC and parallel to BC. It means DF is parallel to BE and DF is equal to BE. So what will happen? DBEF is parallelogram. Okay, so if I am talking about triangle number 1 and triangle number 2, what will be the relation? These two triangles will be congruent. If they are congruent, they will be similar. Okay, now similarly DFCE will also be a parallelogram. So triangle number 1 and triangle number 3 will also be congruent and similar. Similarly AFED will also be a parallelogram, and same case, that is triangle number 1 and 4 will be congruent and similar. So these all triangle 1, 2, 3 and 4 triangles are what? Similar and congruent, which are what? The part of ABC. Okay, so directly since they are what? Equal, so the part DEF will be 1/4 of that one. But how to write it? DBEF, okay, then CFDE and AFED are parallelograms. Okay, so or therefore from figure, triangle 1 is congruent to triangle 2, which is again congruent to triangle 3, which is again congruent to triangle 4. Like this also you can write. Since they are congruent, so they will be similar. Right? So automatically if you will add, therefore area of triangle 1 plus area of triangle 2 plus area of triangle 3 plus area of triangle 4 is equal to nothing but area of triangle ABC. Now since all the 4 triangles are congruent, so what we will do, we will write 4 times of area of triangle DEF is equal to area of triangle ABC. Right? What they are asking, area of DEF. So we have area of DEF ratio area of triangle ABC. So this 4 is multiplying, so it will divide here, and nothing is there, it means 1 is there. So what is the ratios of the area? Area of DEF upon area of triangle ABC is equal to 1:4. So next sum. Now the sum number 6, where it is given triangle ABC is similar to triangle PQR. Then we have to show that the ratio of their areas is equal to the square of the ratio of the square of their corresponding medians. It means what is given, triangle ABC is similar to triangle PQR. Okay, then AD is median of triangle ABC and PS is median of triangle PQR. Is that okay? Now what we'll do, we know that triangle ABC is similar to triangle PQR. Okay, so the thing is what, if they are similar, so their ratios of corresponding side will be same, that is AB upon PQ, BC upon QR and AC upon PR will be equal. Okay, then we know that triangle ABC is similar to triangle PQR, so we can write in this way also, triangle ABC upon area of triangle PQR will be equal to the squares of ratios of their corresponding side, that is BC upon QR side and then AC upon PR square. Okay, now it is already given that AD is a median. So what will happen, since AD is a median, it implies that BD is equal to CD, or simply BD is equal to half of BC. Right? Similarly, PS is a median. Okay, whatever are given, I am writing that only. So QS is equal to SR or QS is equal to QR upon 2. Okay, so these are what all are what information, equation number 2, equation number 3. Now what we'll do, we'll try to prove that either of the ratio is equal to AD upon PS. So easily we can prove that. So what we'll do, we'll take this triangle 1 and we'll take this triangle number 2. So in ABD, so in triangle ABD and in triangle PQS, we already have such kind of sums. Okay, so what we can do, AB, it is given that AB upon PQ is equal to BC upon QR, already it is given. So since it is a ratio, so if you will divide this side by 2, that is BC by 2 upon QR by 2 will also be equal, but we know that BC, half of BC is equal to what? BD, and half of QR is equal to what? QS. So what we have to see? We have to see this first and the fourth part. As well as we know that and angle B is equal to angle Q. Why? Because angles of similar triangles. Okay, angles of similar triangles. Similar triangles are there, that's why they will be what? Equal. So what we are getting, therefore triangle ABD is similar to triangle PQS by SAS rule. Right? So what we will get, therefore AB upon PQ, right? AB upon PQ will be equal to the medians, that is AD upon PS, equation number 4. Now if you will relate this equation number 4 with any of the equation, that is 1 or 2 or 3, so you will get, therefore from equation 1 and 4, AB upon PQ is equal to AD by PS, AB upon PQ is equal to so many things. Okay, that means what? These all are equal. Okay, so what we can do is AB PQ is equal to BC upon QR is equal to AC upon PR is equal to AD upon PS. All four ratios are equal. What we got now? We got these sides are equal, so their squares will also be equal. So the areas of similar triangle, that is area of triangle ABC upon area of triangle PQR is equal to AD upon PS its square, because all four sides are equal, so their squares will also be equal. Sum number 7. In that, prove that the area of equilateral triangle described on a side of a square, okay, is half of the area of the equilateral triangle described on the diagonal of that same triangle, diagonal of that same square. It means that what is given, ABCD is a square. Okay, ABCD is a square. Then triangle ABE is an equilateral triangle on side of square. Side of square. And triangle BDF is an equilateral triangle on diagonal of square, right? On diagonal of square. Now what will happen, since, and what we have to prove that area of triangle AEB or ABE, okay, is equal to half of area of triangle BDF. This we have to prove. So let's go ahead. Since triangle ABE and triangle BDF, it is already given that both are what? Similar, or both are what? it is already given that triangle ABE and triangle BDF are equilateral triangle. Okay, equilateral triangle. Therefore, automatically all the sides will be in the ratio, in the same ratio. ABE will be similar to triangle BDF. As we know that all the equilateral triangles are what? Similar. So, by triple S rule, because, or by triple A also you can say, because all are what? 60, 60 and 60. All three angles are of what? 60, 60 and 60. Now, if we talk about the side, let the side of the square is A. So here this is also A, this is also A. Okay. And if it is also A, then what will be the diagonal? Diagonal will become under root 2A by using Pythagoras theorem. Okay. So if this side is root 2A, so automatically an equilateral triangle is there. So this will be also like this. So means we know, let side of square is equal to A unit, therefore diagonal will become under root 2 into A unit. Right. Now since area is what? Same. Now since triangles are what? Similar, therefore their area, that is A, B, E upon area of triangle BDF is equal to the square of the ratio of square of corresponding sides. So if I am taking say AB and BB, its square, so it will be what? It will be A square upon under root 2 A square, or it will be what? A square upon 2A square. It means it will get cancelled A square, and then area of triangle ABE upon area of triangle BDF is equal to 1 upon 2, which we wanted to prove. So this is what the sum number 7. Now for your home fun, I am leaving this to sum for you, that is 8 and 9, which is what very simple to do because everything is what based on only one theorem. So hopefully you will be doing the practice. Once again I am repeating the thought, whatever is happening in your life, be thankful to that all, because all are these what? Experiences. So let's go on getting some more experiences. Do practice so that you should get a good experience of maths too. So we are stopping here, putting a full stop. So be happy at home, be happy at your home and create a good atmosphere around yourself. Okay, so wait for another video at your own channel, Maths Mela. Till that time, be at home, be safe. Thank you.